up in the VMware Explore Hub Theater, please welcome the Field Chief Technology Officer at Isovalent, Duffie Cooley.
Hello, everybody. Good to see you all. I am Duffie Cooley, and I'm here to talk about Isovalent and Cilium Enterprise, or actually Cilium. So we're going to be talking through like basically what the product does, how it fits into the stack. My plan was to do a live demonstration of Cilium with TKG, but it turns out that I'll be doing that from home because I can't quite get enough of the bits through the wireless internet to make that work today. But I do a weekly video log every week at Echo Live Stream, and you can actually catch it there, and I'll probably stream that. You'll see me tweet about it. I am at Maui Lion on Twitter, so feel free to join us there, and you'll be able to see us. So, who are we? We are, this is a company co-founded by two of my close friends, Thomas Graff and Dan Wentland, and I also get to work with a wonderful person named Liz Rice. Together, they founded a company that basically brings eBPF technology to Linux networking and introduces a kind of a whole new way of thinking about networking as it relates to your Kubernetes clusters or your cloud-native environments. Thomas has been the lead for eBPF and the Linux kernel for some time, and Thomas and Dan and I worked together on a previous technology that was called Nicira, or Open vSwitch. Nicira was like one of the dominant players in the network virtualization space. So what has happened is that we've basically graduated from that network virtualization place where packets were leaving virtual machines, entering into a virtual switch, and then moving on to wherever it needed to go. And we were thinking that you needed programmable virtual switches to actually accomplish this. That product eventually became VMware's NSX. We've actually moved forward a little bit with technology, and especially in leveraging eBPF, we've started thinking about the problem differently. Now we're thinking what we really want to see is something that happens at the Linux kernel layer. Right? So we want to move the entry point of the network not from where it is now, which is basically packets when they leave a network interface, up to the application layer. What if we could make decisions about whether to allow or deny traffic? What if we could make decisions about whether to move your traffic, some percentage of this traffic to some particular service, making service mesh decisions, but making those decisions up at the kernel layer, right? Before the traffic even becomes a packet. So we can do that with eBPF, and that was kind of the founding idea of the company. We are supported in AWS, GKE, we're supported in Alibaba Cloud, we're supported pretty much everywhere. Cilium is now an open source project that has been donated to the Cloud Native Foundation. So the open source project is still thriving, and every week we get to see new folks kind of coming forward and saying that they are using Cilium, which is very exciting. Lots of really great customers and lots of great stuff. So this is kind of what I was referring to before. How do we think about networking today and Kubernetes kind of in disrupting it, right? So moving from that device era where we think about like networking as it relates to interfaces and switches and routers and the underlying stack, how do microservices and Kubernetes and those sorts of things change it? Well, with microservices and Kubernetes, we see an explosion of east-west API connectivity and application connectivity. And when you think about that problem today, you think about the fact that since we're building these microservices, in between all of those services, there's always going to be a network. Fundamentally, we're not terribly good at providing primitives that let us debug or observe or understand what's happening at that network layer, right? This is where we hope to change things, because one of the key values of eBPF as a technology is its ability to provide context, right? In context, and by that context, I'll show you an example of this here in just a minute, but in that context, we're able to show you what connections are being made between different applications in those microservices stacks. And we're able to show you the latency between those things. We're able to show you, was it an HTTP request? Was it a DNS request? What was the response of that DNS request, right? We can expose quite a lot more information at the network layer than has traditionally been available to you. We have other parsers that we have implemented in eBPF and also in our own implementation of a service mesh that allow you to understand service traffic at the HTTP layer, Redis layer, Kafka layer, all of these things. And because we're implemented basically at the Linux kernel layer or at the application layer, we have the ability to extend what we can do in that place. One of the early examples that I saw in a Cilium implementation that really kind of opened my eyes to what was possible was an insecure implementation of Kafka in which you had multiple queues and you had a client that was trying to access those queues. Kafka at the time didn't have a very good authentication layer, and so it was actually pretty difficult to secure these particular queues. And what Cilium was able to do was basically, since we're operating again at that connect layer, we're able to inject authentication, right? Ensure that the client, it actually has a certificate, a client certificate that it's going to use to authenticate to that queue, and then on the serving side, right before it actually passes back to the Kafka side, ensure that there's an authentication end-to-end from the client to the server without having to change Kafka or the client at all, right? So just inject that end-to-end security posture without having to make any changes at the application layer. That was one of the very first examples of Cilium as a technology that I saw, and it really blew my mind. So we think that Linux is a universal cloud native runtime. And we think that, fundamentally Kubernetes is going to be that orchestration layer, as we have seen in, probably a lot of the presentations here at VMware Explorer today. We see, we see like a lot of the application stack moving to it because it has that common API, right? You have the ability to describe the deployment of different applications, how they will interconnect, and how to establish all of that connectivity that you need. At the operating system layer, we're planning with eBPF to solve 3 different problems. The connectivity, how can we actually allow for those pods to communicate with each other? How can we do more advanced connectivity? Maybe we want to send a percentage of traffic to one service and a different percentage to another service. How can we improve the security of it? Like, can we actually provide like that certificate layer without having to make application changes? And we're also trying to solve observability, right? We're trying to basically give you insight into what's happening at that application, at that network layer. And with Tetragon, which was just recently announced by Isovalent, we're also giving you that visibility into what's happening at the application layer. Very exciting. And then finally, security. When we think about applications that are deployed inside of Kubernetes today, there's not really much of an identity for them inside of Kubernetes, right? So you just have a bunch of different pods, and there's no individual identity for those pods today. Most people go to a service mesh to actually pick up this particular capability, right? So if you leverage Istio, you can give each pod its own certificate, and you get this form of identity that you can then use to ensure that applications with a certain identity can access other applications with a different identity. With Cilium, you can do that basically just by deploying the networking layer, right? That's built into Cilium from the ground up. Every endpoint in Cilium has its own identity, and when we're building network policy, we use that identity to enforce it. So the way that we do that under the covers is that we're actually writing an eBPF program for every endpoint in your Kubernetes environment, or every endpoint that represents an application in your Linux environment. And that eBPF program, inside of it, it has a couple of individual specific characteristics. We understand the identity of that endpoint. We understand if it is just like a bunch of other endpoints. We understand what the network policy is that applies to this endpoint, right? So we can see that you have written rules in your network policy that allow it to reach the outside world. You may have written another rule that allows this application to talk to some subset of other applications in some subset of other namespaces, right? We compile all that down into one eBPF program and attach it to that application. And now when that application makes a connect call, even before that traffic is a packet, it hasn't left the network, it's not on the wire, it's still at the kernel layer, right? We can make a decision about whether to allow or deny that traffic at the connect call to the Linux kernel. And we can also make decisions about routing, right? Before we rely on the underlying Linux host's routing table, before we rely on things like IP tables to make routing decisions for us, we can actually make routing decisions in eBPF as implemented by an eBPF program inside the Linux kernel. So every one of these applications that you've deployed in your Kubernetes environment has its own, effectively, very intelligent network stack with a lot of context to help it make the decision about what to do with this traffic. This is available for all mainline Linux distributions, so we have a lot of customers using Ubuntu, Red Hat, CentOS, like everything you can think of is out there, SUSE, etc. So at Isovalent, I have the honor of working with a number of great folks who are kernel maintainers for eBPF, kind of extending eBPF as a capability of the Linux kernel every day. And Isovalent also recently founded the eBPF Foundation. And the eBPF Foundation is a foundation dedicated to basically enabling enterprises and other technologists to actually make use of this technology. So we put a summit on every year. It's coming up in September. And if you want to learn more about eBPF in pretty much any of the different categories in which eBPF operates, so there are people using it for APM or application programming management, there are people using it for networking like us, not just us. There are also people who are using eBPF to handle load balancing with it at very high speed rates. Basically, every packet that you send to Facebook today will go through and will be processed by eBPF at some point. If you want to learn more about eBPF in any of these verticals, you can come check out ebpf.io. And if you go to ebpf.io, you'll see the summit link. It's a registration. It's a virtual event, and you'll get to see a number of really great experts in these technologies, in these verticals, coming and talking about it. And I'll be one of the hosts there, so I'm really looking forward to seeing that. So basically, as we were just describing, kind of taking that traditional networking and then moving it to kind of a secure cloud-native implementation. So your traditional Linux networking, where a connect call would happen, it may move, the traffic, the packet would have to leave end up on the network. IP tables might do some changes to it and that sort of thing, and then you would send it on the wire off to the next pod or the next endpoint. Inside of our implementation, this is an eBPF program associated with that given application, and we have the ability to see what's happening at the process layer. We are able to make load balancing decisions. We're able to give it an identity, and using that identity, enforce a firewall so that we understand that applications with this identity can talk to applications with that identity. We can even do TLS observability, which is a relatively new capability. But because, again, we're operating at that kernel layer, with new changes in the OpenSSL libraries, you're able to actually defer TLS encryption to the Linux kernel. And when you do that, you give us the ability to actually extend our functionality before that encryption happens, which means we can observe what's happening at that traffic layer, whether it's encrypted or not, before it leaves the host. This is an example of the identity-aware firewalling and troubleshooting. So in this example, I actually have 3 different rules, right? I have a rule that allows for any pod that has the identity front-end service and any pod that has the identity back-end service to actually to see whether that traffic was allowed or denied, right? So in this example, we can see that this traffic is dropped. This is why it says verdict dropped. But we also see connections from that front-end service to api.twitter.com, and that traffic was dropped. When we create network policy, we can create network policy that allows for just FQDNs. So I can write a rule that says front-end services are able to communicate with api.twitter.com or star.twitter.com or whatever your internal domain system is, right? And basically, we instrument, again, at that kernel layer, when the front-end service tries to make the connection to that api.twitter.com, we're able to see contextually what connection that is. We're able to see it's trying to make a connection to twitter.com. I have a rule that allows for that. What is the resolution of that FQDN? Here's the IP address that was handed back to that pod when it tried to make the resolve call. And now we actually have a mapping of that FQDN to that IP address. And all of that context is available to me within eBPF. So that's how I can actually enforce FQDN policy, leveraging just Cilium network policy inside of your Kubernetes environments. And as that A name changes or this record changes, we actually, again, detect with every new resolution of that name whether that name has changed. And if it does change, we add that new resolved IP address to the list associated with that record. If the old IP addresses age out, then we age them out of the list, right? So it's actually a very robust, and a lot of people are using Cilium specifically to enable things like FQDN policy. Again, something that people have traditionally gone to a service mesh for, but something that's just in the box without any risk or change to once you've deployed Cilium as a network implementation. In this example, we're showing you kind of the difference between a kind of a traditional network and the Cilium-based observability capability, right? In the top version, you know, if I were going to ask if I come to work on Monday and I tell my networking troubleshooting guys, you know what, I think that somebody exfiltrated a bunch of data from my application. Somebody got in there and they stole a bunch of data. And I can kind of tell that because I have a network log that says that this was the inside IP address and that was the outside IP address, and that outside IP address is very suspect, and a whole bunch of data went to it. Tell me everything you can about what happened on the infrastructure at that time, right? The problem when you start getting into things like Kubernetes and those sorts of environments are that IP addresses are ephemeral. So if your only way of understanding the source of that traffic from inside is an IP address, you're going to have a bad time, right? There's no like mapping it back to like what that application was at that time, or, you know, in many cases people use the same IP addresses for multiple clusters, right? So which cluster was it that did that? You won't. It's going to be very difficult to determine. With Cilium, we emit an event log or an event stream that actually describes quite a lot more information, right? So now, when we actually see that connect to that suspect URL, we can actually emit an event that describes the entire connection, whether it was allowed or denied, by what policy was it allowed, and how many bytes went by, all of that information. And more specifically, we also give you all of the metadata associated with that particular pod. So when that pod made that request, I know it was this pod on this cluster at this time, made that connection to that FQDN, and it was allowed by this network policy. And all of this event data can then be sent to your Splunk or to your SIEM environment, and you can actually turn this into a historical log. So now when you come in on Monday and you say, show me everything about that, you know, I have this source IP, I have that destination IP, I have this FQDN, I can actually make a simple request of all of that data and say, show me everything that was talking to this FQDN. Oh, it looks like maybe these 3 pods in that cluster were, right? Further, now with Tetragon, I can show you what's happening at the application layer. So I can tell you which process did it, right? What files were opened during that period of time. I can show you, you know, I can give you visibility into what HTTP calls were made from that application to anything else laterally within the infrastructure at that time. So quite a lot of information and quite a lot of context about the problem that you're having is available to you in that case. One of the other things that we've been working on, you've heard me say service mesh a few times. One of the other things we've been working on recently is actually moving our product into the service mesh space, because we've realized, you know, that there's a ton of the capability, as I've already kind of expressed, that we already do that people go to a service mesh for, which is pretty interesting. So, like let's talk about some of those capabilities and how we map to them, right? So one of the capabilities is identity-based, right? I want to be able to understand that an application has an identity, and I want to be able to create network policy that allows this application, maybe I want like layer 7 network policy that allows this application to talk to this other application or service, but only at specific paths, right? Traditionally, you've gone to a service mesh for this, and you've inherited quite a lot of complexity for that capability. With Cilium, you kind of get that out of the box. I don't have to make any changes. That's just a part of our Cilium network policy model. Another capability that people use service mesh for is the ability to do service mesh-based routing, like if you want to do circuit breaking or percentage routing, right? And these sorts of capabilities are, again, a part of the service mesh capability that in Cilium that we're developing. So this is actually an extension of Cilium, right? We're implementing an ingress controller that gives you the ability to provide that sort of percentage-based routing and all the advanced routing things that you would expect from a service mesh. And we're doing it all without sidecars. We're not taking on all of the complexity. We're just going through without it. Anyway, if you want to hear more about it, Cilium.io, Isovalent.io, or check us out at Echo Office Hours. Thank you so much. Hello.
Hello. Well, Duffie.
They're hot. They're on. Oh, this one.
You want to turn this off? Yeah. All right.
So Duffie Cooley.
Yes.
You know, one of the things you're talking about is the security issues that we see in networks.
Yep.
Is that an identity issue at heart? And is that kind of what you're getting at?
It can be, yeah. I mean, basically, you know, this is actually one of those things that we learned from that Nicira exercise, or from Open vSwitch, or network virtualization in general, right? Was that, you know, in many of the things that we have invented before, we've kind of re-implemented the network just as it was designed before, without really bringing any other capability to it, right? And so when we were thinking about how, you know, the shape of Cilium and like what we were trying to develop here, we realized that we needed to actually support things like identity as a base primitive in connectivity between things, right? We need that just to be in there from the beginning. So with Cilium, whenever you actually associate an endpoint, whether that's an application in Kubernetes or some other application running on a Linux server somewhere, we give it a unique identity, and then you can write network policy that is like that basically allows you to enforce that network access by identity rather than by IP or by any of that.
But before I go any further, I'm Alex Williams of the New Stack,
Yep.
Duffie Cooley of Isovalent, and my co-host, host of the VMware Tanzu podcast, Michael Cote. Plus, he does a lot of other things. But Michael, we were talking about security, but we were also talking about why do we need this new kind of approach?
That's right. Yeah, you know, so I don't really know much about networking, so maybe you can help me out. But it seems like, and you were touching on this, it seems like what I see from my perspective of ignorance in you know, the last 10 years of networking is like, there's this tension between like static and dynamic. And like those of us who live way up the stack are always like wanting to change things around all the time, to be ephemeral, as you were saying. And it seems like as you go lower down the network stack, they don't like that, right? And so like we sort of like, I don't even know, I mean, tell me what your perspective on this is, but it seems like there's not really even a meeting in the middle. It's like us on the top of the stack are sort of like, all right, well, how about we put some new layers on there, right? And like it seems, I don't know, I mean, that that tension seems, weird is the wrong word, but it's kind of like an oddity of
Unusual.
like, yeah, it's sort of like at some point, and I only mean this in like an exploratory best way, but like, shouldn't the network people figure that out? or like what, where do the cultures like differ, and like, why so many layers?
I mean, there's quite a lot to chew on there. So I'm going to begin from the beginning. I would say that, like, you know, in my career, I have actually I've worn many of those hats.
Right.
I've worked as a network architect for DSL networks across the country, and I've worked all the way up into, you know, basically reinventing networking and network virtualization, and now I'm kind of working on a networking solution that really implements itself at the application layer. I would say that for the most part, what I've seen over time is that a lot of network architectures are now kind of moving toward a place where they are considered plumbing. And you have to think about that plumbing as highly available, can handle all the water or whatever else is passing through.
Right.
You know, that is the biggest part of your challenge, right? And where you're hooking that plumbing up are servers at this point, right? And that's kind of like, that has become the way that we think about that underlying network for the most part.
Yeah.
Right? And now, but that doesn't really, but that introduces a new set of problems, right? So now that we've got this plumbing thing worked out, we're really good at that. We've come up with clause networks. We've come up with all kinds of great ways to handle moving all of these bits back and forth. How can we, you know, revisit or improve the security model of those applications that are consumers of that network?
Yeah.
Now, for the most part, I would say that this is where that division comes in. This is what I mean by that things have changed a bit, right? A lot of network architects are just focused on the plumbing problem anymore. and the application and the developers and the platform security folks, and those folks are now suddenly on the hook for solving that security problem.
Right. They've kind of like that. By they, I mean the networking people have pushed responsibility upward in some actually kind of awesome sleight of hand, right?
Yeah.
Like, because usually, like, again, I have an application development background, right? And you're always, it's not exactly how you put it, but you're always trying to be ignorant of what's below you.
Yeah.
Right?
I
And,
mean,
and this is almost like a reversal of that flow of like, hey, how about you're very knowledgeable of like the layer right below you?
Exactly. And now, but it's interesting now with like different orchestration systems like Kubernetes and others that are out there, what we've seen is that like we're, the platform folks and people who are writing software for the platform folks are thinking about how can we make it so that people who are in the application business can just tell us what should be okay, what should be allowed or not allowed, right? Because at the end of the day, as an application developer, which services your application should be talking to.
Right.
And me as a networking guy, I don't care, right? Like, I just want to know like what you should be doing so that I can put some reasonable guardrails around that. So
Right. You want the people as a network person up the stack to specify what they need. Yeah. I mean, when I hear myself saying that, it sounds ridiculously obvious, but as opposed to
giving you everything.
Proactively being in charge of all the intricacy of the networking stuff that happens, as you're saying, is something as complicated as an app running in Kubernetes, right? There's a lot going on there.
One of the other shifts in paradigm in this particular case that has always really blown my mind is that, from a traditional networking background, you spend a lot of your time like looking for primitives that you can use as identities so that you can write firewall policies that restrict access between things in multiple areas, right?
Yeah.
Say I have databases over here and they have financial records, and I have my applications over here and they have like access to that financial record information. And I want to make sure that only those ones that are supposed to have access to that financial information have it.
Sure.
So I need some form of identity again, right? I need to have some place to start. And so traditionally what I've had to do was I'd say, these applications are only going to have these IP addresses, and then I can say these IP addresses have access to the database. And woe be to anyone who figures out how to get an IP address into that subnet, because they'll be able to get around it and do all that stuff. What's changed, though, is that with a lot of these orchestration systems, now what we're writing network policy is label sets. So we label every endpoint. You see this in Illumio, you see this in Kubernetes, you see this in everything now, right? You just write, you label everything, and then you say, things with this label can talk to things with this label, which as a networking guy, was a huge paradigm shift.
Right.
It made this whole thing so much simpler than it ever had been.
Right, because not only do you escape numbers as your primary currency, but like you're saying, you can start having groups of things that are labeled somewhere.
And it gets back to identity.
Yeah. And again, just the search for it, and like how do we make that identity either as atomic as it needs to be, or at least in a way that we can, enforce that security layer.
But can we back up a little bit, because why do we need all this new stuff?
Oh, yeah, that was the question I was.
That was a question that Michael was posing. Like I was reading a story that you have on the Cilium site about the history of networking, essentially. Yeah. And a lot of it gets down to the hardware versus the software story in many ways. But why? What was happening 10, 15 years ago that put us on this path?
I got to work at CoreOS for about a year before it was acquired by Red Hat, and one of my absolute favorite talks that Brandon Phillips, who was our CTO, gave, I think he really raised the point that where things changed in a really approachable way that really blew my mind. He said every day, another 20,000 people are logging onto the internet for the first time. Yeah. And worldwide, at the time, I think there were 20,000 individuals working in IT that understand this problem. We are significantly outmanned. Yeah. Like we cannot possibly, with the technology and the practices and the procedures and everything else that we had 15 years ago, solve the problem of today, let alone the problem of tomorrow.
Why was that?
At capacity, because there are more people consuming more services, consuming the internet, putting their photos up, getting Gmail, getting all of these applications.
And what resulted from that on the back end as a result? with more people and more people and more people.
So what resulted in is basically a change in the way that we think about infrastructure.
Ah,
Now at the time we were thinking, you know what, if you rack 20 servers and you have an application stack on each of those 20 servers, that was enough.
but it was an overload issue.
Yeah.
And so you couldn't add more servers
Yep.
because you couldn't have enough cable, enough buildings,
Yeah.
enough machines.
And this is where you end up with like containerization taking over, right? Because we figured out a way to actually put hundreds of these applications onto a single server. And we figured out a way to actually manage the life cycle of them so that you could change them very quickly without having to go through all of the time it would take to change that 20 application stack on 20 servers probably.
But now the networking, as I understand it, for instance, with eBPF, is as much about the application, the service, maybe the load balancer, the security layer, the
Yep.
firewall. I mean, you were talking about Facebook, for instance, right?
Yeah.
You know, and how do they use it?
They leverage eBPF to actually handle what they call, I think it's called CAN-TRAN. It's their load balancing layer in front of all of the properties at Facebook. So if you have any service that is a part of a Facebook page, there will be a load balancer, usually more than one, between your phone and say that particular service. And all of those load balancers are implemented in eBPF.
So is eBPF enough?
I think eBPF gives us quite a lot of capability to dig into this problem in a very material way, right? And again, it changes the way that our entry point is. What isn't enough, for sure, is if we're only looking at packets as they enter the network or leave the network. Because, like what I was saying, if you're looking at evaluating networking equipment today or firewalls or any of that stuff today, right? You measure the capability of that piece of equipment in packets per second, right? And this kind of speaks to that scale problem that we're talking about. Packets per second. That's the way you measure it. If it's a firewall or a network switch or any of these things, that's what you're looking at. With eBPF, we can actually make decisions about whether to allow or deny traffic, drop this traffic before it ever even moves up the stack and becomes a packet. We can see that traffic and make routing decisions about it before it even enters the network, before it ever hits the wire or any of that stuff. So really with eBPF, it gives us the capability of actually moving so much closer to the source of this huge scale problem that we can really have a very significant effect in changing the way that we think about the solution.
So, in the Kubernetes world, there's this constant sort of consternation about developers should do this or they should not do this. Yeah. Get involved in things. And what's your thinking and experience in the networking space? Who does this, right? Is it? Because obviously someone needs to come in. Everything, what you're just describing. There's decisions to make there, and even. Yeah, you have day-by-day interaction. Is there now container network admin? What kind of roles are filling that need? Because I assume that if I really know how to convert a screen into PDFs, I'm an application developer, I'm probably not doing that unless I'm desperate. But yeah. What is that role, and do people do it?
I think it's developing. For quite a while, I would say it was the platform. It was the platform team in general that was doing that work, right? Now it's kind of moving into more like a sec DevOps kind of role and that sort of thing, where you have the people who are responsible for enforcing kind of the security posture of the company working alongside development teams to help them understand what changes are needed and how to implement those things, right? In some companies, this is actually like a production engineering role, right? But it actually does move more toward if you are going to be a consumer of this platform, we still need to be able to protect and enforce a reasonable security posture for the company. Yeah. So we need to basically ensure that you get those resources so that you can be a good consumer of that platform, that you can accomplish your goals and still not blow up the security posture of the company.
Yeah.
Right. And so that's where I feel culturally it's changing, right? Traditionally it's been platform, it's been the platform team, whoever gave you that account to that system, but now I feel it's kind of moving more toward people solving this in a production management or production systems role, where you have embedded people in different teams who are responsible for the outcome or the usage of that platform.
Right.
And they're responsible to ensure that they're communicating up, like what.
Right. And so I guess, I mean, I don't know, I'm just making this up in my head, but there's kind of like three functions when it comes to like networking as you're discussing in the Kubernetes world and other things. There's the function of just like your application being able to operate, right? Like, because basically, I don't know, with exceptions that are good or bad, like if you're running an application in Kubernetes, it's a distributed application, so you need a network just to like live.
Yeah, and you don't want to think about it at all, right?
Right.
Think, where am I going to get this IP address? No, right?
And
I thought about the deployment. That should be enough.
Totally,
right? Like,
totally. And then you have, exactly. Then you have the second concern that's sort of like more external facing, like the performance of things, like especially if it's higher scale where you need to add in more load balancers and interact with CDNs and everything.
Yeah.
But then the other thing that also seems like a new and interesting, maybe exciting, like thing is like you can do security better. Like you can do security. I don't know. It's another thing I don't know about. But it seems like you're given more handholds. You're given more opportunity to like do stuff, which is nice to layer on top of everything else there.
Yeah, I mean, something you'll hear a lot of times, in this industry is a thing called microsegmentation. Right? Microsegmentation is the idea that we can, either through the construct of identity or, understanding how to actually get really atomic with network policies and those sorts of things, be able to describe how to segment just some small port of an application from some other small part of an application.
Right.
Rather than gross grain controls. Are you allowed in the data center or are you not? Right? That's like an external firewall problem, right? We're really familiar with how to solve that problem.
Yeah.
But can application talk to application B? Application A talk to application B? How do you solve that problem?
Right. Your west-east, not yours, but the west-east metaphor.
Yeah.
Yeah.
That's where things like leveraging UPF to kind of implement this stuff, they put us as close to that endpoint as we can get.
Right.
And we can dynamically change the network policy or the security posture of that application very quickly without having to go back and configure all these firewalls and all this other stuff. That's the big payoff for this microsegmentation.
Right.
Is that if you can do it and you come up with a reasonable way to implement it, and you allow your developer, say, for example, to look at all the traffic that went by or was attempting to go by in the last couple hours and just pick the things that are supposed to be allowed and write network policy. This is a feature of the Cilium Enterprise UI, right? If you enable that sort of self-service so that people can actually just do the easy thing, click the thing, and make it so that this is now their network policy, and then that goes through an approval process if needed, then you have a much more secure posture because you're securing all the way to the application rather than just to the very large data center, right? Lateral movement, as I think most folks know in security-minded, lateral movement is your biggest security risk. Once people get in, that's a big problem. But if they can get in and own everything else around them, that's a whole different problem.
Yeah, for sure. Yeah, and so like, I mean, as a last thing, well, let me preface this by saying, like, to force yourself to answer the following question, because the answer is always like, it
depends.
It's flow, right? Like life, everything is flow, right? Like when it comes to this type of networking, like, what's your model for thinking about when we're done with it? Not done like we're not going to do it anymore, but that like it's now mainstream, right? Like, DNS is done, right? Like we're not like scrapping to have it be the way that we do anything. So like when you think about it, like how would we know if we're sort of like done scrapping for this?
This is an interesting one because I think it comes down, it's actually, I've worked in Kubernetes for quite a few years and we've asked the same question and I think the answer is the same. It's going to come down to like when it's boring. Like I was saying before, when you are interacting with a Kubernetes API or your CI system or what have you, when you're thinking about how you're deploying your applications, you're not thinking about the network. And that's fine, right? I don't want you to think about that, right? I want to enable you to think about the security of that network. I want to enable you to say, my application over here is not talking to this other application, and I want to know what's happening on the wire between them. I want some observability capability that lets me see that, right? I want to answer that question. These are all things I would consider check marks to tell me the things we've done, right?
Yeah.
Right, and we've done that with Cilium, right? Cilium is an OSS project. I feel like we're at the place now where Cilium is a stable, solid option for pretty much any of these environments. And I feel like it's in a better position to call itself done than a lot of the others that I've seen in the space.
Right, right.
So where do you go from here then?
Well, where we're going from here is, I think, within Isovalent, we say sometimes that if there is a way to leverage eBPF in the stack that would give us some competitive advantage in this market, then the answer is yes. Right? So if we look at Tetragon, for example, one of the other security things we haven't talked about, Tetragon gives us the ability to actually know what's happening, again, at that Linux
What is
kernel.
that then?
Yeah, Tetragon.
What is that?
It is the ability to instrument what's happening at the application layer. Right? So before I said you can see like traffic moving back and forth between pods. With Tetragon, I can show you which process made the connect call. I can tell you what its Linux capabilities, which are like the permission system in front of the Linux kernel, I can tell you what capabilities it has. I can let you write application policy that allows or denies access to specific things within your underlying file system. Right? I can actually move, to different places in the eBPF stack and provide primitives that allow you to improve the security for all of that as well. And that's what's next for us, is like that piece of it, the service mesh piece of it. I think that's where we're headed.
All right, that was fun. Like I said, I'm always pretty ignorant, so every time I talk with a networking person, I feel a little bit better.
Yeah, I got it.
That's right.
I got it for now. A little bit more.
Well, tomorrow, Alex, we have a whole lot of interviews.
Yes.
We got 5 or 6 of them, so if anyone's watching in the live stream, turn in tomorrow. And thanks so much for coming up here. It was fun to hear about. It was you got a nice way of explaining stuff that's not
Thanks, Duffie.
too technical.
I appreciate it.
Appreciate it.
I'll see you next time.
Bye-bye.